Okay, for people joining this live stream, we are talking about incremental language development for Wolfram Language. We have a variety of topics today. The first one is about functions that deal with subsets of things. So let's see, we are looking here. Okay, these are versions of the sequence things in which patterns are, okay. That is a total can of worms. I will be amazed if you can do something reasonable with subset replace. Tony, are you with us here? So, Tony, are you here?
Yes.
Okay. So my first question is, you created these in part to support some Sparkle query type stuff. Is that correct?
Yes. So it's used in the GraphStore project internally.
Okay.
And part of the algorithms reuse part of the Sparkle evaluator.
Okay. All right. So what I would imagine should work. Okay. So if I say, what's it going to do? It's going to give me one of those. Okay. All right. So let's say I say, by the way, how fast is this stuff?
So there are many different situations, and for some they are good, for others not yet. So for instance, if it can be decided in advance which patterns will be very selective, then they are evaluated first to keep the intermediate results small, and that is a huge speed benefit.
How does it compare to Max's C code? Do we know?
I haven't looked.
Max, do you know?
My C++ code doesn't work with arbitrary patterns at all.
I see. Okay. But in the case where it overlaps, do we know?
Well, not really, but it's, well.
Here, let me start.
I don't know.
Hold on. Let me just look at something here. So it's going to break again with the Packlet stuff. Max, has that been fixed?
Yes, it will.
Oh, God. Okay, is that going to be fixed by tomorrow? Is that going to be fixed
I'm
tomorrow?
currently blocked on this, and there is a meeting this evening at 4:30.
Okay, who is that meeting with?
David, Patrick,
okay.
and
all right.
yeah.
Okay, let me see. So I guess I can't do it directly. All right.
Well, there's no set cases yet in set replace.
Right, but there is a replacement. But I don't know how Tony is doing that replacement. So let's take a look at your documentation pages, because the replacement is a huge can of worms because of the order in which you do things and what happens when there are overlaps and so on. Make sense, Tony?
Yes. But in this case, this function is so far only replacing non-overlapping things, because once you replace it, it's not there anymore to be replaced further.
Yes, Tony. But which of the various possible overlapping things do you replace first?
Yes, okay, that is a good question. So below the overview, there are some, in the agenda notebook, there are some other questions. For instance, how do you order the things that you want to find, or in which order do you return them?
Right, but so let me just understand. In subset cases, we don't care because we're going to return all of them, including overlaps, right?
Well, configurable, you can configure that by an option. Yeah.
But that's not the way we should do it. We should do it by true by default, I think.
It's following the precedent of sequence cases and string functions.
Yeah,
Which string function?
There's a string cases, and sequence cases was constructed following string cases.
Let me see what string cases does for this.
So the odd thing here was, and this is something we inherited from string cases and string position, is that those two functions have different defaults.
Oh yeah, I remember that. We thought about that carefully.
Mm-hmm. Yeah, and I think it's related to using the most frequent case, but it's a bit odd that they have different defaults. So the sequence functions do the same.
Okay. So in this case, the default. Okay, but then there's an ordering which matters in subset cases, right? Because I think in string cases, substrings. So it doesn't really tell one the order that it uses, right?
Those are things to be discussed.
No. I'm talking about this case here. I'm talking about string cases.
So, sorry, I think order is not a problem here except for the final ordering of the result. So the structure does not depend on the order.
Well, I don't think that's correct, right? Because
in string cases.
No. In string cases, I think it can depend, right? In other words, if you say, okay, Jonathan, you guys, come on, we can come up with an example of this. The question is, okay, if we have something like this, right? And we say string cases of that. Let's think. If it's the same, I mean, this isn't very interesting other than how many of those it gives. Okay, so it's giving 2 of those, even though there are many more if there are overlaps, right?
Right.
Okay. Let's see, how do we get an ambiguity here? We have to have 2 things where once you've picked one of them from the beginning, right, you can't get another one. Am I making sense?
Right.
And it matters that it's a left-right scan.
Oh, yes, I see what you mean. But with the option and assuming a left-to-right scan, I think the ambiguity disappears.
There are also lengths. You might have alternatives, and then AA versus AAA might cause ambiguity.
Yes, variable length patterns are an interesting case because there it matters whether you are greedy or not. In string cases, is greedy. Yeah, and
Doesn't look greedy to me. Why didn't it come up with AAA?
so if you have, say, A ... it should find a long sequence of A's.
No, but look at this case.
Yes.
Okay, that's a bug. Why isn't that working? See?
Actually, it might not be bug. It just picks one of them. In other words, it doesn't consider every alternative.
Yeah, it considers the overlaps, but it doesn't consider the alternatives.
Yeah.
It
So
depends on the order in which you do the disjunction.
Okay, so this is very screwy behavior. I mean, I just don't think we've been aware of this evaluation order question yet, but we now are aware of it, very much so.
What happens with overlaps all?
Oh, I didn't know there was an overlaps all. Okay, let's try overlaps all here. What does overlaps all do? Oh, that's better.
Nice.
What is it doing?
So yeah, the documentation says allow all overlaps, and true allow overlaps starting at different positions.
Okay, what's the analog of that for Tony?
The argument or the definition of position is not really clear. How do we bring that to the subsets in which the position doesn't matter? So for now, I think true and false make sense, but all, I'm not sure yet.
Okay, so the analog for subset cases of this would be if I have like table 1, 6 or something, and then I say 1, 1, 1, and I do that. Okay, it's giving 2 of those. That's the right thing. So I have just that. It'll give 3 of those. Okay, great. Okay, now if I say overlaps to true, should give. Okay, so how many of those? It should give 6. Choose 2 of those. Am I right? That is 6. Choose 2, isn't it? Come on, somebody knows their Pascal's triangle here. Well, that's encouraging. Okay. That looks very nice, Tony. Good stuff. Okay. These are rather weird examples, if I might say so, but.
Well, they are specifically constructed to point out certain design questions that we might have.
Okay, so start asking your questions.
So if you go to the variable lengths patterns, the question is, how do you want to order each single result? Does the import determine the order, for instance, or does the pattern determine the order?
But by the way, what determines the order in the general case of subset cases? It's the subset that occurs first, is that right? That comes out first.
That is the question that we should ask ourselves. Yeah. So
what do string cases do?
I think in string cases, the question doesn't arise because you are always looking in order. But here we have a choice to make. Do we follow the input order or the pattern order? I think for both, there would be arguments. Yeah.
Let me think about that for a second. Does Jonathan or Max have any ideas about that? So the question is, if we've got, we are picking subsets out of this set. And one subset comes from one pattern.
Intuitively, I feel like it should do a left-right scan of the input set.
That's what I think too.
And then if there's an ambiguity, it should only then care about the pattern order.
Yeah, so if you scroll a little bit further up, yeah, there you can see, down, sorry, the other way. Yes. So we see the whole option 1 thing. There, we first generate the subsets and do a slow search through by using orderless pattern sequence. Yeah. So that would be one choice. And the other choice that I've implemented is determining the search by the pattern. Yeah.
By the way, I have a simple question. Is it the case that, wait a minute, orderless pattern sequence is equivalent to making a function orderless, right?
Yes.
But not flat, right? We have no analog of we have no pattern construct that makes a function flat. Correct?
I think that's correct.
Although we could do it with double blanks and things, presumably. In other words, if we said orderless pattern sequence of something that contains a triple blank, yeah, that's a question. Okay. Okay. All right. So wait a minute. So you're now determined by the pattern.
So you see in the result, the integers are grouped because they are matching.
Yeah,
the
I prefer this one. I prefer this one.
Yeah. So the question is, both results are possible, but they might have different optimal algorithms in terms of space and time complexity. And we have to determine which one do we want. And maybe we should take into account how can they be computed. Yeah.
I would prefer to have the determined by input one. In fact, I would much prefer to have that one.
That follows also subsets itself, which is probably an important precedent here.
Oh,
Yeah.
that's an important precedent.
The only difference to subsets is subsets starts with the smallest by default. And here we are starting with the biggest because we want greedy matching, I think. But apart from that, yeah, it follows subsets.
By the way, why not have a method option in subset cases that determines some of these details? Just for now.
Yep.
Maybe we shouldn't document it. Okay, so this is a subset cases where variable length. I mean, you could obviously output these in any order you want. What is the point?
So the reason why that is important is because how do you define the non-overlapping case? Naively or effectively, you could just delete duplicates by going through the list and then deleting position lists for which you have seen a particular element already. Yeah. So that means this behavior has an impact on the non-overlapping case, and therefore the runtime in which it can be computed.
Wait a minute. I didn't understand that.
So if you want to form the non-overlapping case from those, you could go through them one by one and check which ones have you seen already or which ones do overlap, and keep removing them. So depending on the order of the overlapping case, the non-overlapping case might have a different order. Yeah?
I am way confused here. Jonathan, did you follow that? Did anybody?
Not entirely.
Sorry, I should prepare better examples next time.
Okay, try again, Tony. Are you claiming the answer? You're claiming the runtime depends on the order in which the answer is generated, or what?
I'm saying that there could be such a dependence because depending on which order you want, you have completely different algorithms.
But who cares? I mean, you can resort the output after you've generated it. Why does it matter?
In the non-overlapping case, it's not just the resorting. You get completely different elements.
I see. Okay. In the non-overlapping case, let me just try something actually here. So you're saying, yeah, I understand. So the question is, do you get? I mean, the question of do you go for the biggest matches first? Which does seem like a good idea to me.
So you're changing which things get excluded in the non-overlapping case, which changes the elements that get produced.
That sounds right.
Is that correct? Okay, right. Yeah, okay, I'm with you.
Okay.
It also gives the user some kind of power, because if they can reshuffle the patterns to get a different result. Maybe they want to do that for some reason. Yeah.
I'm going to try a real example here that's kind of complicated. Let's see if I can find a decent one. Yeah, I think I have one here. Okay, so what we should be doing here is take this, and we're going to put blanks in here. So this is this is a subset cases, right? I mean, subset replace. And now I'm going to start off with something like this. So that should fire. Oh, we got to do something to make this work.
You have to create a module.
Yeah. Okay. So now what we want to do.
I think did you mean a sequence of those pairs on the right-hand side as opposed to a list of pairs?
Yeah, I'm going to want to catenate each time here.
So you could say sequence at module.
I hate sequence at. I don't like that. That's what I want this auto flattener thing to do.
Yes.
But here, what is this doing? This is going to insert these in. So if I have a more complicated case here, if I have
So right now, you're replacing two elements by one because you don't have this sequence.
Well, this is a good example. What has happened to what has happened to that thing that is the auto flattener that sort of auto flattens into this?
Okay, it's in the queue, but it's not ready yet.
Okay, so if I say nest list, I assume that this is a curryable creature. Is it a curryable creature? Does set replace the subset replace curry?
So only one of those four functions is currently documented to be curryable because there are issues with options and confusions of rules that we would have to discuss. But in principle, all should be curryable.
Okay, so let's see what this actually does. That was respectably fast. Let's see if we can do it for 15 steps. Let's do it for 10 steps. Let's not tempt fate too much. Well, that was very fast. I wonder whether it's correct. It's very promising. Well done, Tony.
Yeah, so this case is actually efficient, yeah, because that's the one that's also good in Sparkle.
Wowee. Okay. Well, I'm impressed. Let's get this in the system. I'm seriously impressed, actually. Let's do it for 15 steps here. That's getting a little slower. Well, that's grinding. That was 6.7 seconds. And to generate a graph with 7,000 nodes. And by comparison, Max's custom code for this type of thing takes 2.3 seconds. That's very respectable, Tony. Well done.
Thanks.
I mean, well done, Max, also, because I'm sure Max's code is super efficient, but it's still, that's very respectable for something general purpose like this. Okay, I'm highly motivated now. Let's go finish this design and get this in the system. So we're hoping this can go in as experimental for 12.1, right?
Yes, shall we leave the question of the ordering open because it's experimental? I need to study that more, to make a recommendation of what.
I think you should go ahead and try and do whatever you think is going to be fastest in terms of the implementation, which probably is the greedy output with the longest case first.
Okay.
Okay, let's talk about subset replace. Okay, so these, what on earth are you actually doing? Well, I mean, I just ran subset replace and it seemed to do the right, I mean, how could it have done the same thing? Max, can you comment on that? Is what Tony is doing the same default? Let's see whether your graphs are actually the same.
Well, I guess in that simple case, it might be.
But you think if there are 3, like a hypergraph thing on the left-hand side, it'll be more complicated?
Well, I'm not sure, but well, ideally we need to run it through my unit tests and see if any of them fails. That's how we know if it does something different.
Do it. Okay, so Max, can you provide your unit tests to Tony?
I think so. Well, they would have to be adapted, but yeah.
Okay, I mean, it's only, yeah, right. Okay, fine, let's do it. But this is looking super promising.
Yeah, and also it might be a good idea to replace my symbolic implementation with this completely.
That would be cool.
And for that reason, it might be useful to have it to be as customizable as possible.
Okay, what customization would you like?
Well, like different ordering and so on. I mean, you were talking about method option before.
Let's put that in. I mean, whatever Tony can parameterize, please parameterize in the method option. Tony, does that make sense to you?
Yep, okay.
I'm very impressed, Tony, that you managed to get something that's as close to Max's custom code as you have. It's really very good. Well done. Maybe I better not run too many more cases because it may not be as fast for other ones. But what are the names of those method options going to be?
Maybe something related to ordering or sorting, or containing the word ordering or sorting. I'll come up with something.
Okay, all right. Okay, what do we think we're going to do with subset replace? Because clearly there are many possible, it's a very complicated issue of how you do the ordering for subset replace. Yeah, I really would like to bring back that discussion about I mean, the only thing with that auto flattener that we have not figured out is its name, isn't that correct? We know it's semantics, don't we?
Yeah, so we decided to make it, I mean, we were discussing at some point about a second argument specifying the head into which it auto flattens. But I think we gave up because it would be too difficult in held things. So it's only list for the moment.
Yes, I think that's the right thing. What was its name going to be? What was the best, what was the most recent name?
The last thing we discussed was flattened in.
flattened in or flattened into? It isn't really the right.
Sorry. Yeah, for a long time we thought it was flattened.
So just for everybody's recollection of what this is something where if you have a list, you say ABC / dot B goes to flattened DE, right?
Yep.
Well, I mean,
the motivation to have that list was for just in case we want some additional arguments.
Oh, we absolutely want the list here.
Mm-hmm. Okay.
That's the useful case. You've got a list and you want it flattened into something else.
Mm-hmm.
Does it flatten or catenate?
Max's favorite bug. It should catenate.
Sorry,
Good point, Max.
I don't understand.
This doesn't actually flatten itself. So for example, if this was the list DE like that, the result you would get here is A, D, E, C.
Yeah, that's what I would expect.
Right. And Max is making the point that that isn't really a flattening operation.
Yeah, it sounds like it should be catenated instead.
I see. So it's flatten one level. Yeah.
So what? That's very obscure. And flattenable doesn't suggest it will actually do it. I mean, this is in the distinguished story of nothing, right? It's part of the
but I still think flatten is clearer, because if you wanted to flatten,
I kind of do too.
Yeah.
What about unwrap?
We talked about well, but it isn't. It's not. It is not doing the action of unwrapping. It is unwrappable. It is an auto. It is a. You know, it's like a. It's like a. I wouldn't say a bomb that will explode automatically, but you know what I'm saying. It's like it's a thing that automatically unpacks itself.
It's like a delayed flatten.
What about merged in?
See, the problem is, Sandra is making the point, it's more like a sequenced in. I mean, inlined, it is not the right word, but something along those lines. Okay, something like this is kind of interesting. Enlisted, that would be a horrible, horrible pun.
Are we relying on, what heads are we relying on to be the same here?
Nothing. We're only doing this in lists. We're only planning this for lists right now.
Okay.
Hey, could you put yourself on mute, please? Sandra is suggesting in place, which is also not terrible. In placed. I think it's a bit obscure to. Yeah, this is also a splicing thing. The problem is that we need to make it clear that it is not that this function is taking an action. This is the thing that's nice about inlined is that you don't expect that it is doing something to D&E itself. It is merely that wrapper.
Why is that desirable instead of just having that evaluate?
What the heck would it evaluate to?
Sequence?
No, the whole point is, you don't understand. The whole point is we're trying to avoid the insane, badly defined semantics of sequence, okay, of which I would like to point out. If I say A equals sequence of BC, what does it do?
Gives you back sequence of BC.
Well, it's a hack because this would normally turn that into set of ABC, which would be totally wrong.
Right. I like unwrapped.
I don't, because it's not that. I mean, honestly, inlined is the best sentiment here. But it isn't quite. I hate the metaphor with typesetting and code macros and God knows what else.
Right. I would avoid it for that reason alone.
I mean, it's the analog of inlined because it is. What would you call it? Let me just see.
This reminds me of the discussion about subset map, in which we were extracting something and putting something else back. And we were discussing re-insert things. By the way, I was also going to mention subset map in relation to the other discussion of the subset functions.
Yes. Is it consistent?
Inserted?
That's not bad. Yeah, these things being suggested on a live stream like unbracketed. Yeah, unbracketed is kind of the right sentiment. It just isn't it's sort of a weird. Inserted is interesting and not bad.
Yeah, I like it too.
I mean, okay, so look, the things we might have, we've got spliced, we've got injected.
Would embedded have too many other connotations?
Yes. And embedded suggests it's still there.
Right.
I mean, spliced is better in terms of not thinking that it's still there. The problem with spliced is it's a weird word. We did use it for something in version 1.
I like it other than I'm not sure how it plays with this notion of doing just one level.
Oh, no, it's fine with that. Inserted is fine with that. I mean, that's fine. It's much better than flattened because if I say here...
Yeah, it's better than flattened. I'm talking about spliced, by the way.
Oh, you were talking about spliced. Yeah.
Yeah. Yeah, I'm not a big fan of injected.
No, I think it's
means
medical.
Too many things, yeah.
Is this compatible with insert? It's not obviously stupid with respect to insert. I mean, it's basically auto-inserting something. I mean, if I say, okay, what happens if I say this? Insert DE at position. Unfortunately, it does that, which is not
But we have to be insert ABC inserted DE too.
Yes, good point. Okay, so that's what you would actually get there. If you wanted to put those at position 2, that's what you would do.
Looks reasonable to me.
Do you think so? I mean, it's a little weird. So that. Brian on our live stream is suggesting pull out, which
Wait a sec. Insert doesn't remove the B, though.
But that's okay. This is a replacement here. What
Yes.
other operations would
We want to insert a D and an E at position 2. Has nothing to do with the B.
Yeah. Where else would we use this? Yeah, I mean, the problem with unpacked is that it's just so weird. If you see something in a piece of code.
Absolutely cannot use unpacked.
Yeah, I know, for other reasons, because it relates to the internal packing system.
Yeah.
I mean, if you saw X goes to inserted AB in a piece of code, it's not obviously crazy.
And you had enlisted before. What about unlisted?
It sounds very. It sounds.
You can't find that AB in the phone book.
Yeah.
Listless.
Delisted.
No, that's silly, guys. It's too punny. Carl is advocating spliced.
Spliced has its merits.
Let's remind ourselves what the story of splice is. Wow. Cool. We really took it out. We can use this again. Okay, who remembers what splice did? Come on. You guys really? Nobody remembers?
Can you
I've never
click on
used it.
file template?
No. That's cheating. Well, okay, if nobody remembers here, does anybody on the live stream remember? I'm just okay, this is our history moment. I think it was in version 1. The heck is, where is the oh, listing of built-in objects, B8. Okay, drum roll. Yeah, it was actually, this is funny. I mean, aren't we using the same delimiters now that we used in Splice in version 1? Oh, the reason it's Yeah. All right. Well, listen, I maybe it's only me who remembers this. Apparently in this group, it is only me who remembers this. Good. Well, I think it wasn't a great use of the name splice originally, so maybe we are good to go with, I think that would work. I like it.
Okay.
Very nice. Okay, so the description then would be spliced of, it's a list basically. It would always take a list. Represents a list that will automatically be spliced into another list when it appears as an element. But is an expression that automatically be spliced into a list when it appears. Represents. But something represents blah blah blah, in which the E sub I will automatically be spliced into a list.
Represents a sequence of elements.
Say that again. Represents
a sequence of elements.
E sub I, which will automatically be spliced into a list when it appears. Represents.
Will automatically be spliced when it appears inside the list.
Do we want to try to align this with the wording for nothing?
Yeah, let's look at the wording for nothing. Of course, the analog of nothing would be no list or something.
Okay, I got a question. Why do we need the list delimiters? It's implied to be a list anyway.
What list delimiters?
Inside the spliced.
Because I think that's going to be the most common use case. You're going to want to insert something. You don't want to have to say spliced at blah, blah, blah. This is the case that's interesting. By the time you have those things as separate arguments, you might as well just put them in the list.
Well, okay, so you have X goes, replace X with spliced of ABC. I'm not seeing why we have to have a list around the ABC. And
sorry, what? The whole point is, I understand that you could imagine that spliced of ABC on its own would splice ABC in, but I'm telling you, the common use case is going to be, you've got a list, you want it auto-spliced into another list.
Okay, got it.
There may be also packed cases in which we don't want to break packing at any point.
Well, that's true too. Internally, as people are asking, why is it spliced on? Why is it spliced in the past tense? Because
we used splice years ago?
No.
Oh.
Because it is not an action. That's the whole point. It is to be spliced. To be spliced. I don't even know what part of tense. What
splice in JavaScript, for what it's worth, looks like a generalization of insert.
What does that mean? But it's an active thing that goes and inserts stuff, like our insert.
It can both insert and remove elements from a position.
Fine, but that's a different thing again. I mean, this is what we're trying to do here. I mean, okay, it's a similar concept, but yeah, no, it's only for lists. It's really not. It's not intended for anything else. It's like nothing. Represents an element of a list that will automatically be removed. Okay, represents an element of a list that will automatically by the sequence of elements E sub I. That will automatically splice the sequence of elements into the list. Something like that.
By the way, so sequence also represents something that is sort of to be spliced, but we use a different part of speech in sequence. We don't use a past
Sequence
participle.
is a disaster. Sequence should be removed from the system. I don't even think it's correct that it was in version 3. It was in version 1. It just wasn't documented in version 1. We should change that. That's not correct. We should check, but I'm pretty sure it was in version 1 and not documented. Sequence
we should embrace our inner sequence and stop saying that it's a disaster. It's a really useful thing. Sorry, but it is.
Well, what do you use it for, other than for spliced?
Well, that's the biggest.
Okay, name one other thing you use it for that isn't semantically broken.
I have to think about looking through my code, of which there's plenty, but I'm sure I've used it in.
I see it used many times with options. So function, comma, sequence of a list of options.
Yes, apply sequence to a list. For instance, you have your list of lists that you're going to use as variables for find minimum. And then you apply sequence to it.
Why?
That's actually a common use case for.
But why aren't you just saying the n minimize whatever it is, you know, at whatever your list is? I don't understand.
No, because I have the list of objective function and constraints as the first argument. It's all the other arguments that have to be sequenced out. And if I've created them programmatically.
I see, but then the obvious thing to do would be to use spliced and to put your original thing in there, your, you know, objective and constraints or whatever in there, and then your options here, and then that will just turn into a list of obj, cons, opts, right?
That might be the new way to go about this.
See, I'm telling you, we can get rid of sequence.
Yeah. Although, wait a sec, that would be the right way to go about this. You're not going to get rid of sequence that easily, by the way, except that spliced is only going to be splicing in lists, or is the only restriction the list argument to spliced?
What is the?
In other words, n minimize of a comma spliced whatever comma c. Is that spliced going? Your head is n minimized now. Is the spliced going to?
No, it would only work inside the list.
Okay. Okay. Danny won.
Gustavo is pointing out that you when you uniconize, sequence shows up, which is true. I mean, does it actually show up, or does it just automatically splice in?
It does show up, yes.
Oh, look at this disgusting fact. Look at the description there.
that was what I was trying to say.
So splice represents a bunch of whatevers that are going to be sequenced in.
Very funny. Well, it is amusing that we use that same terminology in sequence. The question on the live stream being asked is, should it work for associations as well? Mute, please.
Actually, I wanted to say something though. Liz also in a meeting, but with associations, how are we going to handle the key business? Or am I misunderstanding?
Yeah, well, so the question then is, if you were to splice into an association here, I don't know how that would work. I don't know how that will work.
Well,
Because
nothing
that isn't
doesn't.
What's that? Yeah, nothing doesn't
work.
work in. Right, it sounds like very much like Odysseus and the Cyclops, but nothing doesn't work in associations.
Presumably, if this was going to work in an association, it would want to be spliced of another association, not a list.
That's a good point. But I don't even see how this can work in an association, because I think by the time it's seen the splice there, it's already too late. The thing is already totally confused. And clearly, if we had a key there, that key can't be repeated, so that's not going to work either. Well, I like this, and I think that this really does strongly suggest that its name was preordained, so to speak. Can we go ahead and try and implement this thing? Should be quite easy, yes?
I don't know.
I thought we had an implementation of it.
I don't think we do, but it should follow the same principles of nothing, which was relatively easy.
Right.
Who did nothing?
Constant.
Okay. So, okay. Yeah, no, I mean, I know it sounded funny, but I was serious because I had no recollection of how this was done.
So let's see if Konstantin would be able to do this one too. All right, let's return. This would be really nice to have. By the way, since we're talking about these kinds of things, I am considering this function called collection, which would be an inert, unordered, repeats are allowed set-like thing. How do people feel about this thing? In other words, it is simply, it really is a function that does practically nothing. All it has is a bunch of is the attributes orderless, and I guess it might have the attribute flat as well. Nobody has a yeah.
So this is going in the theory in the direction of multisets.
Yes, you could think of it that way.
I'm not sure it should be flat.
Yeah, I'm not sure either. Anyway, for a different meeting. Oh my gosh, there's still, Carl points out this is depressing and outrageous, but the claim is made. You can't be serious. How can that still be there? Sigh. Could somebody let documentation folk know about this? That function has been deprecated only 5 years. Okay. All right, let's return to Tony's stuff. Any further questions from Tony? I'm very impressed with Tony's thing here. I mean, I guess with subset replace, there are complicated questions of evaluation order, which we are simply not addressing at this time.
Okay.
I mean, but do we have any thought about how we would parameterize them if we were to parameterize them? Do you understand the issue?
Yeah. So in what kind of example?
Well, the case that I'm most familiar. Oh yeah. The other thing. I'm sorry. I want to talk about subset map for a second and whether there's some horrible problem there. So subset map.
It is quite different. And I don't see a way of implementing a mapping function in Tony's framework.
Yeah, I don't think I do either. Subset. Yeah, I think subset map does a fine thing. And, you know, the issue is subset map is saying what subset, whereas Tony's stuff is all finding the subset for itself.
Right.
So, and we would want some generator of subsets that we can iterate over, right?
Generator of subsets. That's a different thing, right? That's actually a thing Ed was working on. Peg was working on this index subset mechanism. I don't know if anybody in this meeting knows about that. That's a general thing.
I do.
And?
Just I do.
Well, subsets itself takes a third argument with an index.
Really? Does Ed know that? Is it efficient?
I don't know. Good question. You know, I also don't know that.
Maybe all in the second argument.
Oh, I want to get the...
No, you want to get... the second element is how many elements, correct?
Yeah, and
probably with a list 4.
Not all elements were found when attempting to take the sequence. What? Well, I mean, clearly if I do that... Wow, that was pretty zippily fast. Huh.
So it's probably...
no, you know what it's doing? It's just taking the binary number, right? It's just taking to get, I think. So if I take...
What is the second argument is how many elements?
In the subset, which I said 4 here.
Okay.
And this is giving the 10,000th. So for example, the first subset with 4 elements, I would hope would be something like 1, 2, 3, 4. And
okay. So
I wonder if the last element is findable as well. That should be, yeah, that looks very reasonable. And everything in between, I mean, there should be 2 to the 100 such subsets, right? Oh, no, not this man. Sorry, 100 choose 4 subsets here.
Right.
Okay, so it's still a respectable number of subsets. Okay. So what was the, okay, so I'm sorry, coming back to subset replace again. There is a question which we have evaded in replace all, which is the replacement order. Right? Replace all has a particular way that has a particular order in which it does replacements, right? How does the replace all, how does replace relate to subset replace? I mean, clearly replace in a flat and orderless, in a flat and orderless function should be equivalent to subset replace, should it not?
I don't think so, because if you use replace, you can replace one edge at a time, while subset replace, you replace a set of edges. So that's the difference.
No, but in a flat function, you can perfectly well replace a set of things, right? In a flat function, I can perfectly well say...
In an orderless.
Flat and orderless function, or actually just orderless, you're right. I could replace 2 at a time.
That's why the analogy to orderless, with orderless pattern sequence there.
Okay.
So the whole idea of this project is to have something even more efficient than orderless pattern sequence, or much more efficient.
Right. But I'm asking the question, how do you parameterize which replacements you actually do? Right? Because in general, you could do a greedy type thing where you try and stuff in, let's say you've got a bunch of pairwise replacements to do. Right? There's many different possible, you've got A, B, C, D, and you can pair anything with anything, but you're going to use them up once you've paired them. So you might do AB and then you do CD, or you might do AC, BD. How do you decide which one to do? Do you understand my question?
Yeah, I see.
So in other words, let's take that example as a specific. Okay, so let's say we do this and we say, well, we can just do subset cases here, I think. And then all we're doing is we're saying blank, blank. Okay, so now we say, that's great, but now we say overlaps to true. And the claim is that overlaps to true will get us everything.
All. True is something intermediate.
Well, it's not clear yet whether all makes sense in the subset functions.
Right, but so in cases, there's not an issue. It's in replace that there's an issue, because replace, it's got to decide which of these it's going to do.
Well, even in cases, there might be an issue if you use the rule form.
That's correct. No, that's not correct. That's not correct, because I can do whatever I want here. I can say, x, y goes to, f of x, y, and it's going to give all of them. It's just going to take the result.
Yeah, it could be that the first argument where you have x underscore, you have another list where you say a double underscore, comma, b double underscore, and then you get different matches or different possibilities.
But it doesn't matter whether there's a thing on the right-hand side or not, right?
Well, you only see the difference if you wrap, let's say, each the A and the B in a list on the right-hand side.
So you're saying here, I say, let's say U double blank, V double blank. Is that correct?
The U and V both in list, because you want that to be one element in the first set. Yeah. So you wouldn't have A, B, C, D there, but lists of lists.
But I think this is already a weird case, right? Because we've got this case, U, V, right? And then that case.
Yes.
This case already. Wait a minute. Why doesn't this case already have the issue?
No. So this one is handled by true and false. This case.
Okay. So what's the case that isn't?
If you have a list of lists in there.
Okay. So let's say table. Let's say I squared. I goes up to 5, for example. Let's just...
And those lists have different lengths.
Okay, all right.
So yeah, it's a very constructed case.
No. It's not that constructed. Let's go through the case, please.
Yeah, you have, for instance, instead of 1, 1, you have 1, 1, 1. No.
Okay. And now what?
And then group those U and V into a list.
Why does that have anything to do with this? It's not going to match.
Yes, because now you're matching pairs. Yeah.
Oh gosh. Yes,
so now there are 2 ways of binding this first triple there. Yeah.
Hold on. Let me look at this. Hold on. So you're saying I'm pairing up a single element with 2 elements here. This is similar to our multiple hypergraph isomorphism case, I think. If Max and Jonathan know what I'm talking about there.
So to say it in a different way, in this case, each element of the list can be matched in different ways. So maybe that is outside the scope of subset cases, or maybe not.
Each element of the list, what are you saying here?
So if instead of 1, 1, 1, you had 1, 2, 3, to better see the difference. And then you also wrap the U and V in orderless pattern sequence, then you would have different ways of matching that 1, 2, 3 element.
You're saying here, I put that in orderless pattern sequence.
Yes, but you still need the list around the orderless pattern sequence because it's.
Well, it seems to be outside of the scope because it's on the level which is not unordered anymore.
Yeah.
What
Exactly.
do you mean? What do you mean by that?
Well, the subset case, a set in subset cases means that the first level of it is unordered, but this has to do with the second level.
I'm really quite confused by this. Okay, have you guys convinced yourself this is not an issue?
Yeah.
But can we come back, please, to subset replace? Because subset replace definitely has this issue, right? In this case here, if I were doing subset replace, it's got to make a decision about what to do.
Oh, it's the issue with replace, not with subset replace.
Why didn't it work?
Overlaps all is not really supported.
Okay, okay. Whoever's typing loudly, could you? Okay, so subset replace does not support an overlaps option. Is that what you're saying? Is that correct?
Correct.
Because once it's replaced, it's made a commitment.
Yes. It's eating up all the ones that can be matched.
Okay,
well,
so
overlaps
this is
overlaps goes to true is going to be a multi-way system.
yes, which we have no way to represent currently. Right, but you're saying it's an issue with replace because you're saying the same thing. I could do the same thing with replace here. I could just say x blank blank y blank blank goes to f of xy. And
Well,
actually,
f of least x, least y.
And who knows what this is going to do? It's going to do that.
Well, we kind of do know because we can specify longest, shortest, and so on the pattern.
Right. So that does that, which is fine. I mean, clearly, if that was a whole tree's worth, I don't think longest is good enough to distinguish those. If that makes sense.
So you can take a second argument of longest to specify priorities.
What does that mean?
So if you have multiple longest, then.
Are you telling me that, or I mean, is that a thing you just made up, or is that?
No, it's assert details aligned. So that would be one way to control that if you want to implement it in subset cases. Of course, we want, but.
Where would we put that in subset cases? A subset replace.
Well, wherever you specify a variable length pattern, yeah, you can specify.
Yeah, but these aren't variable length. This is a different issue here, right? This is how it eats the original list. Okay, so Max, are you claiming, are you guys all claiming that longest is sufficient to parameterize the behavior of replace? I'm not sure that's correct. I'm not sure it's correct when the thing is orderless, for example. I think the case that's bad here, if that original replacement were orderless, right? I mean, we don't have let me just use plus as a symbolic orderless function here, although that has a bunch of other things like one identity properties. If I do that, and then I say this, it's going to do that.
So is the question how to get all of the possible combinations or how to pick one?
How to specify which one should be picked.
Yeah.
Why not have a selection function option, which just takes cases or subset cases and then picks one?
That's very reminiscent of something else you and I both know about.
Well, that's why I
Yeah.
thought about it, but it seems to work.
Right. So in that case, the selection function is simply taking a list of possible things to do and making a decision which one to do. So it could take the first of those, it could sort them in some order.
Right. Right. It's
It
just
sounds
applying
like it's
some.
going to be very slow.
Well, it depends, because we could have something which says, you know, what would it be called? It would be called something like pattern selection function. And it could certainly have some string values,
All right.
like greedy
so
and things like
greedy,
that.
Yeah.
The question is that what is the ultimate way to parameterize this? I mean, it's one thing, so we can say here are all the matches, but okay, so for example, greedy is one parameterization. This is reminiscent of, you know, in recursive function evaluation, there's all this stuff about leftmost, innermost, you know, rightmost, outermost, all these kinds of things. I think it's reminiscent. I think it's the same question. In other words, if you are, you know, if you've got a choice of function evaluations, let's say you're doing a Fibonacci computation, and you say, if I've got f of 10 goes to f of 9 plus f of 8, do I then evaluate f of, and then I've got f of 9 goes to f of 8 plus f of 7, etc. Do I go and run down the leftmost part of the tree, evaluating, drilling down to evaluate f of 7, blah, 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 down to f of 1, or do I, you know, take bigger pieces of the tree and do things with them first?
So what kind of functionality do we gain by this pattern selection function compared to pattern test or condition?
I think there are things that happen because of the globality of it that you can't do with a pattern test. Yeah, I mean, a pattern test is just saying, hello, I'm a pattern, am I going to match? Right? So in other words, comparing matches.
If you want to enumerate all orders, then just comparison wouldn't be enough.
Right. In other words, what you're giving there is a ranking function. You're not giving a rank. You don't. You're just saying yes or no, Tony.
And what would be the arguments? The whole expression or the surroundings? Or
what is this? So why is some device suddenly came to life here and started talking to me? That is very bizarre. Okay, no matter. Okay. Sorry, what were you just saying?
so what would be the arguments that such a function gets?
It gets the candidate results. So it gets the potential matches. What's that?
Okay, so it gets all the results, so therefore it is strictly more powerful than pattern test.
Yeah. Yes.
I see. Okay.
I think that, I mean, that is the ultimate, the question here is, what are the primitives? If you were going to build a pattern selection function, what are the useful primitives for building a pattern selection function? Because you're going to be given a boatload of potential matches here. Let's take this example here, right? You're going to be given the potential matches there. Well, we can actually list them, right? The potential matches are precisely the subset cases matches with overlaps to true. Right? You're going to be given all of those, and then there is a subset of those that, in other words, there's a, this is interesting. There's a dependency tree here, right? Because if you pick one, there are others you can't have. So how do you represent that? Do you get what I'm saying?
Yes.
Jonathan, do you have any thoughts about this?
Not immediately.
But that's an interesting point, which I hadn't really
Yeah.
internalized. There is a hierarchy of these things.
Right.
So
in fact, probably the most general way is you don't want to just return one. You want to give some priority listing.
That gives you a ranking function. Well,
Okay.
I see what you're saying. But it can't be a local ranking function. It's got to be something which
applies over the whole thing. Yeah.
Right. Because in general, right. And your point is, yes, it's not good enough to take one. You are getting a subset of the subset cases that will be used for the replacements.
Right.
Tony, what is the Sparkle interpretation of what we're talking about right now?
So in some sense, it can be considered a special case, because in Sparkle, we usually have lists of 3-element lists. Yeah. So this is a generalization. The only difference, is that set versus list semantics, but it's a detail.
No, but wait a second. What I'm asking is, what is the interpretation of this issue of the multiple forms of subset replace? What is the interpretation in terms of Sparkle queries of that?
So replace the analog in Sparkle is the Sparkle update language, which is very carefully designed that you first pick your matches and then you pick which one do you remove, which one do you insert. So it's not that general. It's carefully designed to be useful in the Sparkle case.
Okay, but what I'm asking is, this particular thing, can we think of this as, this is replacing an attribute of an entity of a whatever, and there are multiple ways to do it, or is there some interpretation? I'm not sure what the interpretation is in the world of sparkly type things, if there is one. Because the thing.
Yeah. So the problem goes away in a very specific way, but I can't explain it easily.
Okay, fair enough.
The phone.
Okay.
Well,
so
for instance, if you select all pairs of cities and you want to do something with them, won't it be the same problem?
Well, so maybe I try to explain it. Anyway.
Yeah. You're right. You're right. It's easy. Max is right. Look, the fact is, if it's like you're replacing pairs of cities by, I don't know what the example would be. Let's say you're replacing pairs of movies by whichever movie from the pair is the favorite one or something, right? And the question is, which pairs do you replace first? If you've got a whole bunch of things, and in all cases you're replacing pairs by, I don't know, the favorite movie or whatever, you're going to get different answers. And in fact, the question of whether you get different answers or not is a confluence question, isn't it?
So in Sparkle, you first compute. So you have a pattern, and there you compute certain bindings. And with them, you determine which edges to delete and then which ones to insert. So there's no real replace operation. It's more first delete some, then insert, or vice versa.
But the thing I described, so question for Jonathan, Max primarily, how does this relate to Confluence? If this thing is a Confluent rewriting system, I claim it isn't going to make a difference. What you do, am I right? Is that nonsense? Which you do first?
No, I think you're correct. Or at least as long as we're limited to the cases where this is guaranteed to terminate, it won't matter. You could, in principle, have non-normalizing replacement rules.
Yes, but what you're saying is the analog. You're talking about subset replace all.
Right. No. But so in a single step, it might not be the same.
Actually, I'm sorry. You're talking about subset replace repeated.
Yes. Yeah. So what you're talking about, I think, would be strong confluence, where it doesn't things reconverge in one step. Complements is just saying that eventually they'll be the same.
Right.
But
in one step, it's not just a reconverge in one step. They shouldn't diverge at all.
Yeah, that's a good point. They should reconverge in 2 steps.
Okay, but
so not overlappiness as in strong conference.
What is the generalization of the notion of overlapping for this? Okay, so the other question then, Tony, is subset replace repeated. That's what we're basically talking about here, which I think in many cases, many of the interesting cases won't terminate, which isn't very useful.
Repeated, that would be different from nest or fixed point?
Well, is replace repeated equivalent to the fixed point of replace all? I think it is.
I think in a very special sense, no. I think there was some discussion a year ago, but I don't remember the details.
Okay, the thing that's bugging me, and we have to wrap this now, but the thing that's bugging me and I'm kind of interested in for a different reason is this question of what the kind of tree of possible, what you can pick in that subset cases example is. In other words, because I could make this, I mean, it's a graph, I think, of what I can pick when, right? From that list, once I've picked f of AB, I have excluded everything except f of BC in this case. f of CD in this case. Once I picked f of AC, similarly, I've determined something, but let me make the more complicated case. If I do this, oops, I did the wrong thing there. If I do this, then having picked f of AB, I have multiple choices left, right?
Yes.
I think this is an argument maybe for having the pattern selection function not take the list of cases, but actually request it on demand.
You mean once something has been done,
then it recomputes. So the pattern selection function would take the current state of the set and the pattern. It would it would call subset cases, and then it would pick one.
Right, but my question is, what are the primitives that are useful in pattern selection function? I mean, we know a particular greedy case where it's going to try, well, it isn't really greedy. I mean, Max, the thing you implemented in set replace is something that tries to cover as much of it as possible. Is that correct?
Well, the thing with set replace is that it keeps a list of all matches all the time. Therefore, I can sort them in any way I like. And currently, it sorts them, well, by age, essentially. But it doesn't try to pack them as many of them as possible.
What does it do? It scans in order, but wanting things which have not been, which are least recently updated. Is that correct?
Yes.
So it tries to do, it goes through in order, and the least recently updated is the one that it will choose to update if it can. Is that right? Or does it go through in the order of least recently updated?
Well, it's so the most recent of the one it has chosen should be as old as possible. That's what it does.
The most recent of the ones it chooses should be as old as possible.
Yes.
Okay, but how does it know? And it chooses the thing, the next thing that will work.
Yeah.
Where
and it
it's
sorts. Yeah. Yeah, and it sorts the matches when they appear, and it puts them in a set in C. I mean C++ set.
Sorts the matches. Okay, this requires more thought, and we ran out of time.
Just one comment. Is this perhaps a subset replaced list?
Oh, yes.
Yeah,
Well,
effectively, yes. Yeah. Just
what-
that the list would be really big in a normal case.
right. Subset replace list is the thing that will generate everything, which we don't want. Instead, we want some kind of selection function which picks out particular subelements in the list.
I see.
Because replace list is doing everything. Do we have a string replace list? I can't remember. I know I've written such a thing.
I don't think so.
I think we do.
Oh, yes, we do.
Okay. Well, so
We're using it.
yes. All right. For people who are curious, by the way, all this subset replacement stuff is highly relevant for the physics project that we'll finally have good things to say about in a month or so. Anyway, all right. Well, sorry we didn't get as far on this list as I had hoped, but I'm still, Tony, you made my day. These functions are working much better than I thought they would. So good stuff.
Okay, great. So what would be the time frame till when should they be in the system?
Now.
Okay.
Right now. I looked at the documentation of subset cases. It looked just fine. Let me just look at subset. I think it might be worth some comments about certainly in the properties and relations and/or the possible issues, you should talk a bit about this replacement order thing.
Yes. Okay.
Yeah, I suspect that this does only the first n replacements is going to be kind of silly, and that third argument should be used in a more sophisticated way. But I don't think this will be a bad thing to have. Great, let's do it, and we'll work at a different time on knitting them into other pages.
Okay.
Okay, good stuff. Thanks a lot, guys, and thanks to folks on the live stream for a bunch of good suggestions. And yeah, okay, see you all later.